If you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, for today our topic is homogeneous and non-homogeneous system. So the system of linear equations where all the constant terms are zero is a homogeneous system. Like a1x plus b1y plus c1z is equals to 0, a2x plus b2y plus c2z is equals to 0, and a3x plus b3y plus c3z is equals to 0. These are the system of linear equations where all constant terms are 0, and this system where all constant terms are 0 is a homogeneous system. Or ax is equals to 0 where b is equals to 0, and b can only be 0 if x is equals to 0. So if x is equals to 0, then only b will be 0. It means we will have trivial solution for homogeneous equations. Trivial means all variables will be 0. The values of all variables will be 0. For example, x minus 2y plus 3z is equals to 0, 2x minus y plus z is equals to 0, x plus 5y minus 4z is equals to 0. These are the homogeneous system because all the values of b or constant terms are 0. So in augmented form or in augmented matrix, we can write it as 1 minus 2 3, 2 minus 1 1, 1 5 minus 4 0 0 0, and in RREF it will be 1 0 0 0 1 0 0 0 1 0 0 0. So the leading entries for each rows are 1. So these are the pivots, and pivot is the only non-zero entry in their respective columns. So all these three columns are pivot columns. Now since all three columns are pivot columns, so we have no free variables here. All three variables are basic variables. So we can write px, py and pz for column 1, 2, 3 respectively. Now from first row we will get the equation x plus 0y plus 0z is equals to 0. Then from second row we will get 0x plus y plus 0z is equals to 0, that is y is equals to 0, and from third row we will get 0x plus 0y plus z is equals to 0, that is z is equals to 0. So here also we got trivial solution when there is no free variable. So trivial solution because values of x, y and z are zeros. Now let's take another example with x1 minus x2 plus x4 plus 2x5 is equals to 0, minus 2x1 plus 2x2 minus x3 minus 4x4 minus 3x5 is equals to 0, x1 minus x2 plus x3 plus 3x4 plus x5 is equals to 0, minus x1 plus x2 plus x3 plus x4 minus 3x5 is equals to 0, where all constant terms are 0. So these are the homogeneous system in the form of ax is equals to 0 where b is 0. Now in augmented matrix we can write the above homogeneous system as 1 minus 1 0 1 2, minus 2 2, minus 1 minus 4 minus 3, 1 minus 1 1 3 1, minus 1, 1, 1, 1, minus 3, augmented by 0, 0, 0, 0. In RREF, this will be 1, minus 1, 0, 1, 2, 0, 0, 1, 2, minus 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, augmented by 0, 0, 0, 0. Now leading entries for row 1 and 2 are 1. So these are the pivots. And pivot is the only non-zero entry in their respective column. So these are the pivot columns. So we can write px1 for first column. And similarly, third column is also a pivot column. So we can write px3. And column number 2, 4, and 5 are non-pivot columns. So, and we know that free variables correspond to these columns or non-pivot columns. So for column 2, 4, and 5, we can write fx2, fx4, fx5. F is for free, and x2, this free variable associated with second column, fourth column, and fifth column. Now from first row we will get the equation x1 minus x2 plus x4 plus 2x5 is equals to 0, and from second row we will get x3 plus 2x4 minus x5 is equals to 0. Now we know that x1 and x3 are the basic variable, where x2, x4, and x5 are free variables, means we can take any values for these three variables. So now write x1 and x3 in terms of free variables, x2, x4, x5. So from row 1 we will get the value of x1 as x2 minus x4 minus 2x5. Similarly, from second row we will get the value for x3 as minus 2x4 plus x5. Now since x2, x4, and x5 are free variables, means we can put any values for these free variables. So let's take three parameters r, s, and t, such that x2 is equals to r, x4 is equals to s, and x5 is equals to t. Then x1 in terms of parameters r, s, and t will be r minus s minus 2t, and similarly x3 will be minus 2s plus t. Therefore x1, x2, x3, x4, x5 is equal, x1 is r minus s minus 2t, x2 is r, x3 is minus 2s plus t, x4 is s, and x5 is t. And this is the parametric equation, or we can write it as r times 1, 1, 0, 0, 0 plus s times minus 1, 0, minus 2, 1, 0 plus t times minus 2, 0, 1, 0, 1. So these are the three vectors we got. So we can write it as r v1 plus s v2 plus t v3 and this is the linear combination of these three vectors. Therefore, the solution set is span v1, v2 and v3. Now the non-homogeneous system where ax is equals to b and b is not equal to 0 here. For example, x plus 3y minus 2z is equals to 5, 3x plus 5y plus 6z is equals to 7, 2x plus 4y plus 3z is equals to 8, and here b's constant terms are not 0. So in augmented matrix we can write it as 1 3 minus 2, 3 5 6, 2 4 3 augmented by 5 7 8. So in RREF we will get 1 0 0 0 1 0 0 0 1 minus 15 8 and 2. So the leading entries for row 1, 2 and 3 are 1. So these are the pivots, and pivot is the only non-zero entry in their respective columns. So all these three columns are pivot columns. So we can write px, py and pz for that, and there is no free variable here. So now from first row we will get x plus 0y plus 0z is equals to minus 15, that is x is equals to minus 15. From second row we will get 0x plus y plus 0z is equals to 8, that is y is equals to 8, and third row will give us 0x plus 0y plus z is equals to 2, that is z is equals to 2. So we can see here that these are non-trivial solutions with no free variable here. So with free variables we will proceed as we did in homogeneous system. Like if after RREF we have an augmented matrix in the form of 1 minus 1 0 2 0 0 1 1 0 0 0 1 0 0 0 0 augmented by 1 1 2 0. So here leading entries for row 1, 2 and 3 are 1. So these are the pivots, and pivots are the only non-zero entries in column 1 and 3 only. So column 1 is a pivot column and we can write it as px1. Similarly, column 3 is a pivot column and we can write it as px3, and column 2 and 3, 2 and 4 are non-pivot columns, so they correspond to free variables. So x2 and x4 are free variable here. So from first row we will get x1 minus x2 plus x4 is equals to 1. From second row we will get x3 plus x4 is equals to 1. From third row we will get x4 is equals to 2. So 2 is fixed here for x4. So value of x4 is 2. Now since x1 and x3 are basic variables and x2 and x4 are free variables, so now write basic variables which are x1 and x3 in terms of free variables, that is x2 and x4. So from row 1 we will get the value for basic variable x1 as 1 plus x2 minus x4, and from second row we will get the value for basic variable x3 as 1 minus x4, and the value of x4 is 2. So x1 will be 1 plus x2 minus 2 is equals to x2 minus 1, and similarly x3 will be 1 minus 2, that is minus 1. So x1 is equals to x2 minus 1, x3 is equals to minus 1, x4 is equals to 2. So now let's take a parameter r such that the free variable x2 is equals to r. Therefore, x1, x2, x3 and x4 is equal. x1 is r minus 1, and x2 is r, x3 is minus 1 and x4 is 2. And this is the parametric equation, which can be written as r times 1 1 0 0 plus minus 1 0 minus 1 2. Therefore, solution set in this case is span 1 1 0 0 plus minus 1 0 minus 1 2. Now let's take an example with the matrix A is equal 1 2 2 4. Now let's first solve it for homogeneous system. So in homogeneous system, Ax is equals to 0, that is B is 0 here. So the matrix A 1 2 2 4 in RREF will be 1 2 0 0, and the leading entry for row 1 is 1, so this is the pivot, and pivot is the only non-zero entry in first column, so first column is a pivot column and second column is non-pivot column. So y is associated with second column, so y is a free variable here. So from first row we will get x plus 2y is equals to 0. Now since x is basic variable and y is free variable, so write basic variable x in terms of free variable y. So from first row we will get x in terms of y as x is equals to minus 2y. Now let's take parameter r such that y is equals to r. Since y is a free variable, so we can take whatever parameter we want. So x will be minus 2r. Therefore, xy is equal minus 2r and r, and this is a parametric equation which can be written as r times minus 2 1. So solution set in this case is a span minus 2 1, which is a line. Now for non-homogeneous system where Ax is equals to b, that is b is not equal to 0 here. So let's take the same matrix A, that is 1 2 2 4. So suppose in RREF we got the augmented matrix as 1 2 0 0 4 0. Then the leading entry for first row is 1, so this is the pivot, and first column is the pivot column because pivot is the only non-zero entry in this column, and second column is a non-pivot column. So y is a free variable here. So from first row we will get x plus 2y is equals to 4. Now since x is basic variable and y is a free variable. So write basic variable x in terms of free variable y. So from row 1, x will be 4 minus 2y. Now let's take parameter r such that y is equals to r, since y is a free variable. So when y is equals to r, then x will be 4 minus 2r. Therefore y is equals to 4 minus 2r, r. And this is the parametric equation, which can be written as r times minus 2, 1 plus 4, 0. So solution set in this case is span minus 2, 1 plus 4, 0. So solution set for homogeneous system for the same matrix A was span minus 2, 1, whereas this is the solution set for non-homogeneous system. Now on xy plane, the span minus 2, 1 is represented by this green line, that is ax is equals to 0 for homogeneous system. Now for 4, 0, let's move 4 units to the right, and then this blue line represents ax is equals to b, or span minus 2, 1 plus 4, 0 for non-homogeneous system. So for the same matrix A, ax is equals to 0 and ax is equals to b will be parallel to each other. So homogeneous system and non-homogeneous system for the same A will be parallel to each other. Our next topic is linear independence and linear dependence. Thanks for watching.